But all of them actually.
Okay.
Thermometer. There's
What
a
kind of
thermometer.
okay? What kind of measurement did you know?
Centimeters, feet, inches, kilometers, miles, and then there is liters,
Okay.
milliliters,
Okay.
kiloliters,
Okay.
cups,
Okay. Okay. Uh.
and
Okay. Continue. Continue. Yeah. Yeah.
have I said liter yet?
Yeah. 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 You've said it.
Yeah, yeah, I did, I
Uh.
did. Okay.
Other than ruler, is there any tool of measurement that you know other than
Uh,
ruler?
yes, there's the. He showed me a protractor, thinking that I didn't know what it was.
Ah, I think I know what
Yeah, the
you meant.
ruler that is used to measure angles,
Oh,
degrees.
degrees. Yeah, I don't know the translation in English. Busur. Have you heard about it?
Oh yeah, 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 yeah.
Busur.
That's the yeah,
Yeah, yeah, the circle thing, right? To measure a an
the
angle.
semicircle thing.
Yes, a semicircle thing. Okay, what is English? It's an arc. Arc. An arc. I think it's an arc.
No, it's a protractor.
A protractor. Oh yeah, yeah, that's what. Yeah, yeah, protractor. Yeah. Busur is much more comfortable to say, yeah, instead of protractor. Busur. Okay, okay. Did you know how to use it, Bex?
Yes.
Okay, okay. Have you heard about? Mm, have you heard about? Mm,
Thermometer,
yeah, thermometer. Yeah, okay.
gas gauges,
What was it?
gas gauges.
Gas cages.
No, gas gauge.
Gas.
Here, here, here.
Okay, okay.
Mm,
Gas gauges. Ah, okay, okay. Yeah, of gas gauges. This is a fuel gauge, isn't it? This is a fuel gauge. A gas
yes.
gauge, in the other hand, will measure the pressure in a room. Yeah, pressure gauge. Yeah, kilometer per hour gauge. Yeah, yeah, yeah. This is a speedometer in English. In other words, it's a speedometer. Speedometer. Okay. Oh yeah.
Mile per
Miles per
hour.
hour. Miles per hour? It's not really common to use miles actually. In speedometer, it's usually used. Okay, thermometer. Oh yeah, okay. What kind of unit did you use in the thermometer? Is it, you know,
Degrees Celsius and Fahrenheit.
degree? Degree is uh, well, degree is not the unit actually. Degree is
Yeah, it's Celsius and Fahrenheit.
yeah, yeah. So, do you know
Degrees
others?
Celsius, degrees
Do you know
Fahrenheit.
other units?
What's the name? There's the
It
other
start
one.
with an L, with an R. It start with an R. Balance,
No,
balance. No, 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 no. It's not
no,
balance.
not this, not this.
Electric balance.
Mm,
Oh, yeah, 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 yeah. Okay. Electric. It's a, what was it? Electric balance. Yeah, electric balance. Okay. Did you know other units of temperature? Other units. You've said there are Celsius, Fahrenheit. Yeah, there is other units in measuring thermometer. Did you know?
yes,
Did you know it? No.
I know that there are multiple units, but I don't know what the name of those units are.
Ever heard about Kelvin or maybe Reaumur?
Oh yeah, 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 yeah. That's
Yeah.
extremely super hot.
What was it?
It's extremely hot.
Well, it depends. Yeah, it depends. Well, maybe. Um, well,
It's
one.
for extreme heat. It's used for extreme heat, like for example, the sun
Oh
or
yeah, Kelvin. Yeah.
mountain.
Because it's too hot that we cannot measure it in Celsius. It will be, well, exaggerating. Yeah, because
Then
yeah. Okay. Yeah. Did you know why there are a lot of units
wait,
in
let me see. Kelvin.
different different. This is different Calvin. Yeah. Different Calvin. Calvin. Alvin is the other guy. The chipmunks. Okay. So you learn
That
about science then for today. This is science, right? Measurement.
yes,
Oh,
yes.
okay.
Did you know that the wider it is, the more hotter?
The more horror, yeah. The higher it is, always. Yeah. That's how a thermometer
And did
works.
you know that if there is infinite heat, it doesn't even have a color anymore? It's just nothing.
Oh yeah, really?
Yeah,
That's what your
in
teacher said.
science, no, but another
Oh,
teacher said. So if
oh,
something is infinitely hot,
yeah,
the color from tests and the test, not from testing other suns or something, we can't reach that, but testing on computers, they found out that but what's the name, the light thing, the blue is
yeah.
more hotter, white hotter, but
Yeah,
after some time it will become nothing at all. It will
yeah.
become invisible.
Oh,
But if you
yeah.
even come near it, you will become ash. Well,
Ah,
not ash, because
yeah.
you just disappear. That's how hot
Mm-hmm.
it is.
Yeah. That's why different for different temperature, yeah, fire has a different color, has a different color. For example, if you lit up your stoves, what was the color, Lex, in
So
the
what?
color, the color in of the fire in the stove?
Blue, blue,
Blue,
and red.
right? Blue,
Sometimes
right?
red. Some
Sometimes
most of the
red.
time, if you do a little fire, it becomes red.
Mm-hmm.
But if you do a big fire or the most highest, it becomes blue
Yeah. Good. Did you know why the color was blue?
because it's very hot.
Yes, good. If you see the picture in your screen, one of those is color temperature, if I'm not mistaken here. So blue is rated as one of the most efficient fire that exists because it has a higher temperature. Therefore, yeah, in order for us to boil a water with with a blue fire, it will be much more efficient compared to uh, we uh, we burn the water with a red red fires. Yeah, that's why. Okay, that's why it will even though it might be consuming much more gases compared to the red fire, it will be much more efficient. That's why. So never never play with stove, yeah. Never play with stove bags, okay? Because it will immediately
Unless you're
burn.
eating firecrackers.
What was it?
Nothing.
Fire platter. Okay. Well, okay. What science? What other science that did you learn for today? That you learned for today?
Oh, the about sinking and floating. About
Ah,
items that float and sink because of density. And turns out all you need to do is do a detailed thing, answering questions on only one thing. Like there's like if I remember, there was like 18, 18 different ones that you can pick, but you can only pick one and only one, nothing else. If you do
Okay.
more, you don't get graded. If you do none, you don't get graded. Like if you do none, of course you ain't gonna get graded, but you can only do one out of 18.
80. One out of 80?
18.
Oh, 18. Oh, I thought 80. Wow, 80. Okay. Okay. Did you know how a block, for example, can float in water or an object in general? Did you know how it can float in water?
The what floats?
What was it?
What floats?
The what?
The what floats?
The what floats?
No, what floats?
Ah, okay, okay, okay. Yeah, but not a very good reasoning, but okay, I appreciate it. Did you know how can it float fundamentally? I mean, logically thinking, yeah, logically thinking, the
Mm-hmm.
the block has a weight, right? Has a weight on it. And then you put
Mm-hmm.
it in water. It's supposed to be sinking, right? But how can it be floating when the mass, the
It's
weight?
called density.
Yeah, okay,
All
okay.
right, I've already been taught about this. Don't teach it again.
No, okay,
No
okay,
need.
okay.
No need.
Okay, no need, no need.
Teach me about the stuff I can do with it, and maybe other maths about it, but not about density. No, no more.
Okay,
Too
okay.
easy.
But did you know what is the history of density? The
Yes.
his What was it?
The history?
Yeah, the history of how people before us found the concepts of floating itself.
No.
No.
Oh, kind of.
Oh, kind
I
of.
don't really know specifically, but I know that because ships long ago started with using I mean wood. Because if you go to a river or somewhere, you can see sometimes that there's multiple pieces of wood floating on the water. They found out about this, and like maybe they were island hopping and want to go to other islands without building $100,000 bridge. They used a boat.
Okay, okay. But there is a much more longer back to the
Yeah,
history.
like that is the simplest I can do.
Okay, okay. Did you know who found the concepts of floating? The name of the person? It's a Greek feature. It's a Greek figure.
Knew it.
Did you know about it?
Yes.
Who's the name of the inventor?
Oh, I know that it was Greek, not who the inventor was.
Okay, okay, okay. His name is Archimedes. Does it ring a bell?
Archimedes?
Yes.
Ah, here it is. I know what this is.
Yeah. Archimedes. CF. No,
Yes.
no. No. Different. Different Archimedes.
Oh, the other one that is named after him. I
Yeah,
mean,
yeah, yeah.
yeah,
They,
this guy.
that's the Archimedes. Yeah,
This Archimedes,
this
not the
Archimedes.
other one that was
No,
named
no,
after
no, no,
this
no,
guy.
no. Different Archimedes, Bex. Different Archimedes. Okay.
The
Did you
one
know the story?
he says Eureka and all.
What was it?
He likes to say Eureka.
Eureka, no. No, different, different. So, basically, Archimedes want to test whether a gold is a gold or not. Okay, so,
Oh yeah,
if
yeah, yeah, I've heard about this. He
heard
drops
about
things in water. I mean,
yeah,
no, he kind of weighs it and see how pure the gold is or
yeah,
something.
how pure the gold is. Yeah, how pure the gold is. So to test it out, Archimedes put the 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 substances. Yeah, we call it just the substances. We don't know either. Is it?
Substance,
Yeah, I mean
substance. Wait. Substance is mostly used for liquid materials.
Ah, but substances in chemistry can also be solid. It can be liquid. It can be gases also. Yeah, this is for chemistry. Yeah, maybe you learn it furthermore in maybe in
I want to learn chemistry. Don't talk about chemistry, because last year school I was supposed to stay in MYP, but because I went here I could, and there I seen chemistry magic, and I really like science and all, but here I was just like plopped off to the first day I was there, like I did not know anything about science at all. She taught me about moons again.
moon.
Moons.
Oh, okay.
She teach me about everything, the exact same thing again, but in my opinion, like, no offense, but in my opinion, it's kind of boring.
The chemistry.
It, oh,
Oh
not
yeah.
chemistry. It's still called science, but later I will be teach chemistry. But I need to be told the simple stuff first, which I already know. But maybe because I'm
Oh,
still new to the school, she doesn't know yet. If
believe me.
I'm actually saying true words coming from my mouth, which I am.
Believe me believe me when you will be in high school or maybe in college, learning chemistry is not all is just basically learning about how to memorize every rule in it. There's too many rules in it, Bex.
Not
Yeah,
too
because
many. I know
well,
lots of rules.
oh okay,
From
okay.
safety rules, the rules of how not to mix
Well, that's
chlorine with water.
uh-huh.
You know what
Okay.
happens when you mix chlorine with water?
Yeah. What will happen then?
What a
It will.
hydrochloric acid.
Oh
No,
no,
that's a
no.
different formula.
Ah, yeah,
It
yeah,
is
yeah, yeah.
possible
Ah,
though,
yeah,
but
yeah, yeah,
it's
yeah. We
called
learn
the yeah.
in high school. We learn about how the what was it? Yeah, I would say the chemical reactions of chlorine with the water in writing. Yeah. So,
It
yeah,
becomes it becomes acid. It's a
yeah. It become acid.
dissolver.
Mm.
It's called hydrochloric acid, hydro and chloride,
Yeah,
which is
hydrochloric
chlorine and
acid.
water.
Okay, okay. Let's not talk furthermore about chemistry because I get uh tomorrow I have a chemistry exam, so I don't want to talk about chemistry for today. Yeah, I have a chemistry exam for
Wait, don't
today
you need to
tomorrow.
test and what? Don't you need to prepare for the test?
Well, I will after this, Max. That's why. And I'm kind of exhausted with all the formula that existed there. Yeah, you know, when you were in college, you learn about
Just keep it simple.
symbols, and then you learn about rules, and there's a bunch of rules.
Wait,
There this rule, that rule, bunch of
you
rules.
need
There's
to learn
expressions.
a trick. I know a trick that makes it way more easier.
Oh, okay. What was it?
The symbols. Take the symbols, and for example, let's say, uh, you know, uh, density, for example.
Oh, density. Yeah, row,
Like
right?
it's it's simple. It's easy. It's just what's that?
What was it?
Density,
Density equals to.
density, density. Oh wait, I forgot that one.
Ah, okay, okay. Let's not talk about it later. Furthermore, okay, okay. Let's
But the
take
thing is, just make the symbols into words,
yeah.
and
But
the equal, like for example, the equal signs become an e, and
yeah, okay, okay.
like for example, oh, this one. There is there's centimeters, millimeters, kilometers, all that. You can just do it simply by doing like a word thing. But
mm,
from the start of the word, take one letter, make it into a different word, and for example, it becomes King Henry died by drinking chocolate milk, for example.
Yeah,
It's
let's see.
true.
Oh yeah,
Yeah. Yeah. Let's see.
King Henry from England died by drinking
Yeah.
chocolate milk.
Ta-da.
Henry the Fifth. Oh, I'm sorry, I don't know. King Henry died. Oh. So this is how so you memorize the metric unit. Oh, okay. King
Yeah.
Henry died by drinking chocolate milk. Oh, okay. But the problem is, Bex, we the knowledge of knowing the metric system itself will not help you in the test. So yeah, there's a bunch of rule that you should memorize. Yeah, in there's
Going
so much
on.
exception, but I appreciate your help. I appreciate your help. Okay, let's talk. Okay, let's talk about other thing. Yeah, other thing. Yeah,
No could. No more couldn't.
yeah. No more chemistry, please. Okay. Okay. Maybe for today we'll learn about what about statistics?
Ooh,
Have you heard
ooh,
about
ooh. Ah, no, no, no.
average?
I want to learn something that I learn, or like because I'm learning something that already learned. I want to learn something else.
Okay, what
Oh,
was
what's that
it?
name? It's called. It's like guessing, but in a smart way.
Okay,
Not
which
an
one?
educational guess. It's
Yeah,
like a
educational.
way to educational guess, but
Mm-hmm.
it's it's true. Like it's true, even though it's a guess.
Mm-hmm.
I forgot how to do it, but it's something like that. It goes something like that. Do you know?
Oh, I still haven't got a clue on what you were toward into.
Mm,
Okay, what about uh what about we continue about mm,
uh, uh,
ever heard about combinatorics, Bex?
sorry,
Combinatorics.
combinatorics.
Yeah, it's a study of math in learning about the chances of something to happen.
Isn't that similar to statistics?
Statistic is about data, right? Data. We learn
Yeah,
about
it's like a sub of statistics because it uses statistics to help
probability.
us.
Probability. Have you heard about
Yeah,
probability?
probability, chances,
Yeah. Combinatorics is
like
basically
rolling a
probability.
die.
Yeah, good. Yeah. So, well, in higher math, statistic and probability can actually be linked in each other. Okay. But for now,
Mm.
let's learn about the basics of probability first. How about that, Bex? How about that, Bex? Or maybe we continue our algebra.
Good.
Do you want to
No,
learn
probability.
probability? Okay, probability. Good.
Yeah.
Probability. Okay, let me share my screen.
Green.
So you haven't learned about probability then in schools.
Learn?
Have you ever learned about probability in schools?
Yes.
Oh,
At
okay.
schools. School. Haven't learned it here yet.
Oh, okay. Where did you learn it from then?
The exact last school,
Oh,
but
the
now I forgot about it.
oh, now you forgot about it. Okay. Let's see. Yeah. So, what did you know then about probability? I want to know what did you know. I want to know
I
what
know
did you know.
it's but then I still remember something about how you do it, like which what is the bigger chances of she, like for example, this is Shirley. Shirley has wants to buy a secret, the mystery boxes that has toys in them, but she doesn't know what it is. At the back there is six of them, one of which she wants. What is the higher probability? Her getting what she wants or her getting what she doesn't want, for example.
Mm-hmm.
In this case, she probably will get something that she doesn't want.
Ah, okay, okay. Good, 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 good. Okay. So the probability basically is the you want to know how likely a phenomenon can happen, right? Basically, that's what
Yes,
probability is, right? You want to know how likely something to happen, okay? But you
yes,
cannot make sure that it will happen. We just
yes. It's
yeah,
like a, as I said, it's like rolling a dice.
yeah, it's a rolling a dice, yeah. Okay, but but what is guaranteed by the phenomenon is that we took example from the rolling a dice, yeah.
Yes,
The number that came out can be one, two, three, and so on, right? Until six, right?
yes,
But we know that the result of the phenomenon must be a number between one and six, right? Yeah,
yes,
because the dice has six sides, right? Maximum. That's
yes,
what right. So that's what
yes.
should yeah. Okay. So
There's a
let's
D10 too.
yeah. Okay. Good. Good.
Why don't we just use the D10, like the D that has 10 sides,
Ooh,
so we
10
can make.
sides.
Yeah, there is. There's even one with 20.
Oh, 20 sides with the dice. Yeah.
Yeah, it's used for D&D. Here,
Yeah.
let
Yeah.
me grab it. Okay,
Probability.
you can write the stuff. I need to grab something.
Okay. Okay. Likely.
Okay. Okay, I found it.
Where is it?
Here it is. It goes from 0 to 9 instead of 1 to 10.
Ah, okay, okay. So, okay, good, good, good. Okay, so, okay, let's see. Yeah, the art of finding the likeliness of a event. Yeah. So,
Not only
uh,
of event, there's multiple stuff you can use for it.
yeah. So there, yeah, maybe there will. Much better. There will be a much better definition from it.
Like gambling.
But what was it?
Like gambling.
Yeah. No, no. Yeah. Well, gambling is about it's about probability, also about probability. But let's not use it for something bad. Yeah, okay. Do not gamble anyway. Yeah, because
No
well,
gambling.
do not do gambling. Once you are jumping into the world of gambling, you will never comes out of it.
No,
Okay,
no, I'm fine. I'm fine.
okay, you're
I'm not gonna
fine,
use
right?
any money for gambling. I'm playing those fake gambling games. It's still gambling, but you don't use any money.
Okay, okay, okay. It's okay. It still can be tolerated. Yeah. Okay. It still can be tolerated. Okay. Let's see from the question. Yeah. Okay. Let's see from the question. Okay. I have these questions.
Ooh.
Okay. So I want you to yeah. So Maria travels to school either by walking or bicycle. So you have two choice, right? Walking or bicycle.
Yes.
The probability she cycles to school is 0.75. If she walks, the probability that she is late is zero point 0.1. If she cycles, the probability that she is late for schools is 0.05. Now the question is like
Okay.
this. Okay, I have to
Is it percentage? Is that a percentage?
you don't have to use percentage, yeah. Just use it as it is, okay? Now, the first task is to complete the tree diagram, okay? So,
Ooh.
showing the appropriate probabilities, okay? So, okay, this is the phenomenon, yeah. This is the event. This is the start, yeah.
Wait, zero. How many? Like what number to what number? Like I know it's some number to 0.75, but is it 100% to 0.75?
Yes,
Ooh. Those
yes.
are. Ooh. Okay. So
Okay, good. Let's complete this diagram, yeah. This is one. There is a fill out the blank line here, the blank section here. So what is the value for this Bex? What is the chances of Maria is
okay,
walking to the schools?
99.25.
99.25
Yes.
percent. This is in percent, right?
Percent.
Percent.
Yes.
So in decimals. Oh, I'm sorry. This is not in percent. Yeah, this is in ordinary number. Ordinary number, not the percentage.
Yes.
Yeah.
0.75
Yeah. So what about the
and 99.25.
now? Here's the thing. This is not in percentage. This is on percentage.
Oh wait, so
Yeah.
it's kind of like 100%, but instead of 100, it's just one.
One. Good. Good. Yes.
Ooh, so that means that's 75%
Yes. This is
and
75%.
0.75. Okay.
Yeah.
Uh, if so, then the probability of walking is 25.
25 what? Percent or just 25?
0.25.
Good. Yeah. So you have to differ between when to use percentage, when to use decimals. This is decimal, right? This is decimals. Yeah. So, the total. Why did you subtract it with one Bex? So this is 0.75, right? You get the number
Yes?
0.25 from subtracting one with 0.75, right? True?
No.
Oh
I
no.
actually I actually just did this. I pulled out 7 and then see 3, but because the 7 is a half, then that means there's still a 2
Ah,
and a
good,
half,
good.
which is 5,
Yeah, yeah, yeah.
which is faster.
Good, good. Yeah. But the concept is why the concept is like this, Bex. So the question asks that the question say that Maria traveled to school either by walking or bicycle. That means the probability of Maria taking by walking or by bicycle is 100%, right? In total, one, yeah. Let's just use what decimal, yeah,
Yes.
one. Now we don't know by walking it's how many, by bicycle is how many, but we know that by bicycles the probability is 0.75.
So we just, if you want it in this case,
Yes,
which is, and might be in your opinion faster,
yes,
1 minus 0.75, which
yes,
is
good.
0.25.
Because the total has to be one, right, Bex?
Yes.
Yeah,
25 to 75 is
good. Now
I.
the same goes for the next cases. Okay. She said the questions said that if she walks, okay, if she walks, the probability that she is late for school is
Oh,
0.1.
I know, I know, no, no, no. This
Ah,
is
good.
this is extremely easy. Okay,
Yes.
so the probability of late is 0.1, which is kind of easy.
Yes.
For the second one, it's like 0.1 minus 100 minus 1, which is a lot. Wait, no,
Oh,
100 minus 10.
yeah,
Oh, wait,
100
yeah,
minus
100 minus
10%.
10.
Don't
So
forget. It's
It's
percentage,
9,
yeah?
so 0.9.
0.9. Good. So what about this one? The cycle for the cycle.
So it's similar, but this time there's a 0.05, the half of 0.1. So that means it's a 0.95
Which one? For which one?
for the not late.
0.95. And for the late?
5. 0.05.
Good. Okay, next question, yeah. What about this one?
Which
I
one?
have another question.
Oh, okay.
I think we'll be learning by doing question, yeah. I think you already knew the fundamental, right? Yeah, so I think it's not really a big problem for the fundamental parts for the fundamental material. I think it will be much better if we learn by doing the problems, okay? By doing the problems. Okay, what about if I have this kind of question? Can you see the question? Can you see the question, Bex? Hello, Bex.
Hello?
Okay, so this is the questions. So I have this data. I have this data. In a
Mm-hmm.
recent projects on the relations between the gender of 150 science students at college and their degree subjects, the following set of data is collected. Now, I want you to find the probability that a student chosen at random is male.
Ooh, so which class are we talking about the probability? Is the probability from biology, physics, chemistry, or the whole
Nah,
entire
the
subjects?
question asks for a student chosen at random. That means the question doesn't care about whether it's a biology, it's a physics and chemistry.
Now this is easy. This is just easy. Okay,
Yeah, okay.
first we don't, if the question doesn't care about the subjects, then to be honest, why should we care? Add up 40, 16, 35. That's the number for M. 15, 24, and 20 for F.
So,
Let's see. 40, 30. Why am I using my fingers just to count basic? No, whatever.
this is basic, yeah.
7, 80,
Come on,
80,
Bex, you can do it
80.
easy lah. This is easy lah.
Okay, 91.
91. 91 male, yeah.
91 equals M. M equals 91.
M male is equal to 91. Okay, good.
91.
91. Okay, and then
Okay, 15, 20. So 2024. 2, 2, 4. 4 plus 1, 5. 50. 5 plus 4, 9. 59.
this is the number of
Females.
females equal to
59.
59. Yes, okay, 59. So what is the probability then? Let's call it n of a, n of male, yeah. N.
Okay.
Oh, I'm sorry. Let's just
No,
replace
it's
with
M.
p of male.
Oh,
The
M
probability.
and F. M and F. M is
Huh?
male. M is male.
Okay, male.
M.
M. Like this,
M.
yeah. The probability
Yes.
of finding a male is equal to
The probability of finding a male. Okay. So, first, the second step I will probably do before we
yes.
jump into the conclusion
Mm-hmm.
is to add up the numbers together to see what the 100% is in this
Ah,
case,
good.
which is
Okay. What is the
91 plus
100%?
59.
What was
So
it?
first we do, because it's kind of easy, we just do 9 plus 5. 9 plus 5 is 14, 140. No, 150.
150. This is the total student, kan?
Yeah, total students or the 100%
Okay.
is 150.
This is for 100%. So we want
Okay.
to find the male, right?
Okay. So the half. So half of 50%, 50% of the students. So, ooh, this is hard.
Okay.
I know that the total student is 150, and the what's the name? The half of the total of students is what's the name? 75. The problem is I
Now, I'm giving you a hint, yeah. To find a probability, you don't really have to find the percentage. You see that
okay.
in finding a probability of an event, yeah. So finding, and maybe I'll go back from this.
I found it. I found it. I found it. I found it.
Okay,
I
okay.
finally found it. Okay,
Found it.
so the female is 59 and the male is 91.
Yes.
So roughly, extremely roughly,
Ah,
we can say that the female is 50 and the male is 100. Roughly. This is not done yet.
okay,
This is
okay.
like
This is
the
only approximation, yeah.
making it simpler, okay?
Okay.
So let's say male is 100, female is, so the female will be 50%, but that's not true. Yes, that's not true at all. Actually, no,
Yeah, yeah, yeah.
it's actually 150 divided by 3. That's is near the female, but not near. So we do 100% divided by 3 and 150 divided by 3.
Okay, so okay. Did you
Okay.
did you want me to give you a hint?
100. What's 100 divided by 3? Okay. Uh, uh
I'll give you another hint, yeah. I'll give you another hint.
yes.
Here's the thing.
Yeah, yeah, yeah.
So if you want to find a probability of A, for example, okay, you want to find A from an event, okay? Now, you can find the probability by uh you find the number of A divided by the total samples, by the total populations. Let's call it S. Do you
Okay.
understand this? So for example, if I have, oh, okay, okay.
Okay, so probability of male is male divided by female?
Number, the total population is male plus female, right?
Yes.
Nah, so, yeah. So if we bring it to here, the concepts, yeah. So the probability of finding male is just the same as we divide between the number of males divided by the total population, which is consists of male and female. So male
Yes.
and female. Therefore, the number of male is 91.
One.
Number of female and male
59.
is
Oh wait, 150.
150. So this is the probability. You don't have to find a percentage. Just do it like this. Understand? It's like this, Bex. If you have 5 cards, yeah, and then you have two cards, two cards with heart. What is the probability of finding a cards with a heart, Bex, in these 5 cards?
Hmm.
Okay,
Hmm.
you have five
That's
cards.
weird because we don't know how because in the 5 cards we don't know how many cards have heart in them, right? Or is there exactly
Exactly,
two cards
exactly.
with a
Two
heart?
cards with heart from five cards. We know that it had two cards with
So that
heart,
means
which
there's
is
three cards that isn't a heart.
yes, yes. That means in probability of finding cards with heart in this stack of cards with five cards in it equal to
It's I need to remember.
based on the hint that I have been giving you. So it will be
Oh, so that means 2 divided by 5.
yes, 40%, right? Yeah, 2 over 5 is 40%. If you convert it into percentage, that's the same. Or maybe a much more simpler example
Two
will be
divided
if
by
you have two
5.
cards, two
Oh,
cards,
okay. I kind of get it. I kind of get it.
kind of get it.
Yes.
Two cards,
But I still don't understand why I'm doing this.
well, like this, two cards with one card with heart. So the probability,
One with heart 50-50.
yeah, now that's why make it makes sense because we just uh dividing the number of the probability that we want, the number of the thing that we want, divided by the total the total probability, right? The total number,
Wait, one divided by 2 is
right?
1 divided by 2 is half.
A half, right?
Yes.
You get the idea?
Okay. Yes.
Nah, that's why we do it like that, right? Because it is just the same as uh we divided. For example, if I have like this, yeah, again, yeah, two cards
Yes.
with two hearts. What is the probability of finding hearts with two hearts in this stacks?
Okay. 100.
100%. You must be getting heart, right? Because all of the
Yeah.
stacks of the cards is consist of heart. It cannot be other than heart, right, Bex? It must happen. That's why the probability is equal to 1.
Unless the cards don't have hearts.
Well, that means the card is adding the number of the cards, right, in the stacks. That will it means that it has 3 cards. It cannot be
Oh no, that's not what I meant. Like in a deck of cards, the deck of cards might not even include hearts at all.
that
But in
means
this case it
yeah.
does.
Yeah, for example, yeah, 2 cards with 0 heart. That means what is the probability of
Zero
the
percent.
0% because you don't have any heart cards in the stacks of cards, right? So that's the intuition in getting the how to do probability, okay? So you don't really
Mm-hmm.
have to remember the formula like this. No, it's just a notation, yeah. But what I want to emphasize is about the understanding on the intuition on how to get the number. Okay. Okay. Let's do another questions. Yeah. I want you to do another questions. Okay. Have you ever heard about the Venn diagram, Bex?
Mm. Yes.
Okay, good. So, a Venn diagram could help you to solve probability questions because, well, again, yeah, as you know, yeah, in order to determine the probability of an event like we did earlier, we have to know the number, right? The number of the number of the event divided by the number of the total samples, the total population, right?
Yes.
Now, the Venn diagram is useful to show that. Yeah. For example,
I kind of forgot what a Venn diagram is.
huh? What was it?
I kind of forgot what a Venn diagram is.
Oh,
I've
okay. Let
heard of
me.
it, I've seen it, but I forgot what it is.
Okay, like this. Have you ever? This is
Oh,
the Venn diagram.
oh, yeah.
Yeah.
The
Ever heard
second I
about it?
saw it, yes, so many
Okay.
times to
Okay.
differ. It's used to differentiate and similarize,
Yes, good. To characterize, right? To characterize a
to
group.
characterize.
Good. Okay, so I want you to complete the diagram, Fan. So a group of 30 students were asked about their favorite toppings for toast. 18 like peanut butter, which is A, yeah, denote by A. 10 like jam. 6 like neither. Show the information on the Venn diagram below. Okay, usually when we do Venn diagram, we
I
start
know it.
from the well. Okay, Bex.
Okay, so because 18 equals to A, you put 18 on A in the A circle, also known as the left circle.
But here's the thing, Bex. There could be a student who like peanut butter and jam.
Yes.
Yeah, so the the A, so it could be in this region, right? You know what the
Uh-huh.
meaning of this region, right?
Region.
The this one, the shaded area. You know what is the interpretation of the shaded area in this?
Yes.
What was it?
It's a mix of A and B.
Yeah, right. So, uh, 18 like peanut butter is consist of people who just like peanut butter and also people who like peanut butter and jam. So 18 is not
Yes.
the net number. It is still mixed up.
Yeah, so eight, 18, some of them, like some people who likes jam may also like peanut butter, and
Good.
the
Yeah.
people who like peanut butter might
Yeah.
also like jam.
That's why we always start from the neither first, from the outside region. This region from the outside. Now we know that
Yes.
6 like neither. That means
6 outside.
yeah, 6 outside. Good. And then we start now. How many students left?
So wait. So there's 30. 30. Wait.
Okay.
30. 30. 30 let's say wait. Oh wait, no, this is a net. The there because there is 6 plus 10 plus 18 still leaves a few people, and that
Yes.
few people probably likes peanut butter and jam.
Good. Yeah.
Ah, okay,
Yeah.
so that
You
means
you can do it like this. Okay, you can do it like that.
so
But also do
secondly,
another method. Okay, good. Continue.
so that means let's do 28. 28 plus 6. Okay, wait, what? Okay, this is now weird.
What
It
was it?
became
What is it?
34.
So 34 because it is mixed up bags because there is student who like peanut butter and jam and it is mixed up
Yes.
in this A and this B. So we have to determine first we have to determine how many people who like butter and jam. How many students?
Ooh, this one is hard
Ah,
because there isn't a single hint,
okay. The
but
hint
it's
is
still
okay. The hint is like this, Bex. We have we have known that 6 like neither, right? That means from 30 student, 6 student
from the
is like
34.
yeah, which is left with 24. Now, that 24 is made up from this region, which is student of uh the student who likes peanut butter only and also consists of student who like only jam and also consists of student who likes both of them. which is in this region. That means mathematically, I could say that the total of 24, you have 24 students, right? And it has to be
No, there's
consist
28 students.
of
24 dong.
24.
6 yang enggak.
Iya, kan 18 tambah 10. Oh iya, 24.
28, yeah, 24, right? So, yeah. So, as I said, the 24 has to be consist from the student who likes only peanut butter, and student who only likes jam, and also the student who like both of them.
Yes,
PBG, yeah. Let's just call it PBG. Okay. Now,
peanut butter jelly.
peanut butter and jelly. Yeah. Okay. Now, did you want another hint, or did you want to think about
No,
it?
no, I already understand it now.
Oh, okay, good.
Okay, so 24, 24. So that means
Use the number 8
Oh, yeah.
and 10.
Because 10 plus 18 is 28. So that
Yes.
means there are 4 of them. 4 likes peanut butter and jam.
Good. So, okay,
So
okay.
that means it's 24 minus 4.
And it will be,
Oh wait, no.
yeah, yes.
No, no.
And not
No,
24, not
uh,
24.
10, yeah, 10 minus 4, 6. So 6
Yes.
for A.
Yes.
A is 6.
Oh,
And then
A is 6.
B
A
is
is
14.
A is 6. Remember, A
Uh,
is
18.
18 minus. So the 18 will be minus by
4. Yes, 6.
A.
Oh wait, no. Oh yeah,
18 minus 4.
Okay, so peanut butter is 18.
Yeah.
Not 10. Okay, so that means uh 14 for A,
14.
and then 6 for B.
6 for B. Good. And then in the
4.
middle will be
4. 4.
4. Good. And if you add up everything in this, it will be equal to 30, right? Which is the
Yes.
number of students. 6 plus 14 is 20. 20 plus 4 is 24. Plus 6 is 30. Good. Congratulations, Max. Good. Now, mathematically speaking, you can write it like this. Yeah. Let's just assume that the number of people who like both peanut butter and jelly is X. Right?
Mm-hmm.
Now, we know that the number of people who like peanut butter, the total is 18. Right?
Mm-hmm. Yes.
Now, if you want to know the people who like only peanut butter, it will be 18 minus 8 x, right?
Yes.
Yes, and the same goes for the ng, the number of people who only like jams. 10 minus
Okay.
x equal to 24, and the all of them has to be equal to 24.
Okay.
Now you can do the math. 18 plus 10 is 28. Minus x plus x is 0, and then you left with minus x. This is equal to 24. Now you add both sides with x. That will be 28 equal to 24. I'm sorry. Yeah. 24 plus x, and subtract both sides with 24. It will be x equal to 4. That means x is, don't forget, x is represent what, Max?
4.
Yeah, x equal to 4, but x represent what, Max? Don't forget.
PB&J.
Yeah, the number of people who likes PBNG, n of PBG equal to 4. That means if we have the n PBG is equal to 4, that means the number of person who like only jam is equal to 10 minus x, right? 10 minus 4. 6. The number of PB is 18 minus 4. This is 14. This is how you do it without guessing. Yeah, Bex, yeah?
Yeah.
Yeah,
No.
so this is much better. But I think that you already got the intuition. I think that's great. Yeah, that's already great. That's a good steps. Okay. Okay, let's do the other questions. Yeah. Mm, okay, I want you to. Okay, the four. Okay, this is. Now I want you to the probability. Yeah. Okay, I want you to do the probability. From this diagram, I want you to find the probability that a randomly chosen student from the group likes peanut butter, given that they like jam. This is quite difficult. Okay, I want you to find it. Find the probability that a randomly chosen student from the groups likes peanut butter, you know, but you know that they like jam. Now, what is the
Mm-hmm.
difference, Bex, from our previous question?
Okay. So we know that there's 18 people who like peanut butter,
Yes, 18 people who likes peanut butter
and four of them also like jam.
also like jam. Good.
So that means the 18 is 100%.
Good. Okay, good.
And how do
Oh,
we?
oh no, no, no. The
Oh, yeah.
100%. The 100% is not 18, Bex. Now, what they know that
100% is
they
30.
like jam, given that they like jam. From that, you know that certain people they like jam. Now, from that people who like jam, you want to know how many of them who likes also peanut butter. Get the idea, Bex?
Mm-hmm.
So the probability will be 100. Do 100% deh, Bex. 100%. Who's the 100%?
18.
Nah, 18 kan the number of peanut butter who like peanut butter.
Mm-hmm.
Now, we want to find.
Oh, yeah.
Ah,
30%. 100% is 30.
Oh, the 30. Well, the 30 is a mixed up, right? Mixed up between people who like peanut butter, who like jam, and also like neither, right?
So
You
that
want to.
means 30, 38. I mean 34.
No, not 34. What is the 100% here, Bex? Who's the 100% in this context?
I thought it was 18 because we want to know the percentage of getting the ring, percentage of getting X in the group of 18.
Nah, you from the questions, the 100% is person the person who like jam, because given that they like jam, that means from a group of people who like jam, you want to know how many from that groups who likes peanut butter. That means 100% is who, Bex?
10?
10. Good. Yeah, because given that they like jam. Yeah. So here's how to what was it? How to draw it in your head. Yeah. How to visualize it. Yeah, visualize it. Yeah. So in the beginning, you have 30 student, right? You have 30 student, and then
Mm-hmm.
as the question goes on, you want to find a randomly chosen student from the groups like from the groups who likes peanut butter, given that they like jam. The given comes first. The given comes first, Bex. Given means that we know that from that 30 student, we want to observe people who like jam, and that from that people who like jam, we want to know who likes peanut butter. Get the idea, Bex?
Mhm.
So from 30 students,
Okay.
we pick people who like jam, given that they like jam, right, from the question. And then from that group of people who like jam, we want to know how many who likes peanut butter. That means the 100% is the jam. And then we want to from that find who like jam, how many who likes peanut butter. So the percentage will be how many, Bex?
40%.
What was it?
40%.
Huh?
40%.
Can you do the fractions first?
Hmm?
Uh, the fractions like this, like previously.
I kind of did it simple. Do you know how?
How?
So I made 10 into 100%, which is kind of easy.
Yeah,
And the other number is 4. So
yeah,
that
good.
means 10 minus 4 is 6. And in 100, 100 minus 40 equals to 60.
Mm-hmm.
The only difference is we're adding a 0 on the back of each number that we're using.
Mm-hmm.
So that means if 4 people in the group of 10
Yes,
likes
good.
jam, likes peanut butter, that means that 40% of that group likes peanut butter.
Yeah, good. Yeah, okay. So mathematically, it will be the number of people who likes peanut butter in group of jam. Yeah, in group of jam divided by the number of uh group of jam, group of jam, right? So the number of people who like peanut butter in a group of jam is 4, right? And the group of jam
Mhm.
is equal to 10. So this will be 4 over 10. You can answer it like this, or maybe if you may, you can change it into percentage, 40%. Okay? Easy question, yeah, Bex, yeah?
Mhm.
40%. Good. Okay. Do you want to do another question, or we just end it for today and for and things for today?
It already ended? Or not?
Uh yeah,
That was
it's supposed to be, but if you want to do another question, I'll be your guest.
I didn't know it was already 6, but
Yeah,
I don't really have any questions.
everything feels very fast, right?
Not this time. Yes, this time. Not last time.
Last time it's quite long, yeah, for last time. Okay, you want to do another question, or you just want to end it for today? Let's just call
It's
it a day.
okay.
Huh?
I call it day.
Let's just call it a day. Okay, good then. Okay. Uh, maybe as usual, I'm gonna share my the notes for today, and also pray me for the best. Wish me luck for the chemistry test for. It's actually in Saturday. In Saturday, so hope for the best for me, please. Thank you. Okay.
What is it, Kak? Nggak kedengaran?
The
Ah.
test. Yeah, the chemistry test.
Oh,
Iya,
amin. Mudah-mudahan lancar.
mohon doanya semoga lancar.
Terus,
Okay, Bex, ya. As usual ya,
Bye
I'm
bye.
also gonna
thank
set the
you.
record. Okay? Bye bye, Bex. See you later.
Bye.
Bye bye.
Bye.